of the first derivative. And you're like, the first derivative? I didn't know there were any others. And it's okay for now, but in your headings later this will be useful to you because we will distinguish between the first one and other ones that you might work out. So, the first derivative, or the derivative, okay? You remember what the derivative is, another name for it, where it started off with, was rise over run. That's what first principles is, okay? So we call this the gradient function. So therefore, if what we're really talking about is the sign of the gradient function, okay? Another way of saying that is the derivative tells you about the gradient, and whether it's positive or negative, okay? So we say, if the derivative, let's call it dy on dx, okay? If it's positive, that means the graph is increasing. It's going up. Okay, and conversely, if the derivative, the first derivative, the gradient function, if it were negative, then the graph is decreasing. It's going down. So let's do a really quick example, right? Y equals x squared. You guys know what this looks like. Okay, so when you take the first derivative, or the derivative, you just get 2x, right? So when you think about 2x and what this looks like, okay, let's just graph 2x. Okay, what does the derivative, and the sign of the derivative specifically, what does it tell us about the graph? Well, at x is less than 0, right? The derivative is negative. You can see there, the derivative is below the axis, so that means all of these values over here are negative. So that means the graph is decreasing, it's dropping, which corresponds to the fact that the left-hand side of the parabola is doing that shape, going from upper to lower. And of course then, after you pass the origin, the derivative becomes positive, so it turns around, and here, it's increasing. Okay? So that's pretty simple stuff, right? You might have remembered I introduced a new word a few lessons ago, which was really long, monotonically, which basically just means always. Okay, so when we say something is, a function is monotonically increasing, for instance. Okay, for instance, let's think about y equals, say, 5x. Okay, monotonically increasing. I know it's monotonically increasing because when I take the first derivative, okay, it's just going to be 5, right? Because you're taking that, the power goes down, and so on. Okay, this is really 5x to the 0. Okay, so this number here, the gradient function, is always positive. Any value of x you put into it, it just stays at 5. Okay, so this is monotonically increasing. Okay, and the reason is because I don't know if you knew this, by the way. You know how therefore, right, is 3 dots? It looks like that. So you've got like A, therefore B. You can actually say it upside down. It's not very common, but A, therefore B is the same as B because of A. Okay, so anyway. So you're mind blown, right? It's upside down. I've just mind blown you for the rest of the day, so you can be content. You've actually learned something.
I can't learn anything anymore.
Your brain is full. Monotonically increasing because dy and dx is greater than 0, and here's the important bit, right? For all real values of x. You see that? Right? Any value of x, dy and dx will always be positive. Okay? You need to know that because sometimes they'll say, prove that such and such is monotonically increasing or decreasing. Come in.